Okay, so again, learning target is still able to solve polynomial equations of degree 3. And so just like throughout all of the previous unit 3, unit 4, we're still just trying to find different ways of factoring these polynomials. Of course, the only twist with unit 4 is after we factor, we want to solve, right? But the skills hopefully are getting to be kind of commonplace, second nature for you. But with this PowerPoint, I briefly want to kind of show you what is kind of going on behind the scenes and where we're going to try and get eventually. So, of course, if we have a linear equation, that means it's first degree, right? We just have x to the first power. You only get one answer, right? So in this case, if we saw a straight line, in this case, it says, hey, look, x has to be 4, right? The solution where that line crosses the x-axis is 4. And so if we have a straight line, we're either going to have one answer, provided the line crosses the x-axis, or if it's parallel to the x-axis, we could have no answer, or if it happens to lie on the x-axis, we have an infinite number of solutions. But most of the time we say, hey, it's going to have one answer. Second degree equations, we're going to have at most 2. And of course, this is the situation with the parabola. And we spent a lot of time in a previous unit studying parabolas. And we can find most often that we'll have 2 points of intersection. Sometimes we could have 1 point of intersection. And then sometimes there's no real solution where the parabola does not cross the x-axis. Again, for real, we usually use that script R. So last unit and this unit, we've been trying to factor and then solve third degree equations. And at most, we'll get 3 solutions. So if you notice in this first graph, it looks like it crosses the x-axis at 2, 5, and 8. And so those would be our 3 solutions. Sometimes we get a double solution like here. We'd say, hey, the solution is just 4 and 8. That's because 4 was actually a double solution to the equation that made that graph. Occasionally we get a single solution, and of course this is when we have a perfect cube, right? So this would be a graph of x minus 2 quantity raised to the third power. It says, hey, there's only one solution. It's a triple solution of 2. And then sometimes we have this weird situation where there's one solution because the second and third solutions are complex numbers or imaginary numbers. But that's what we're going to be working toward, right? At some point in time, not only are you going to be able to find the solutions to these equations, but we're going to kind of graph these equations. You're going to find the maximum and minimum values of these equations. Some of that we'll get to this year. Some of it would be a future math class. But this kind of gives you a context of what we're doing and why we are trying to find these solutions. Okay, so let's go through some examples. Again, I look at that number 50. It's not a perfect cube. So I'm thinking, my best bet's probably synthetic division. Again, I try 2. If 2 doesn't work, I'll try 3. If 3 doesn't work, I might try 5. And then I might loop back and try -2 or -3. Let's drop. 2 times 1 is 2. Let's add. -12 plus 2 is -10. Multiply. 2 times the -10 is -20. Let's add 45. And a -20 adds up to 25. Multiply. 2 times 25 is 50. That adds up to 0. So there's no remainder. So 2 is a solution. And of course, that 1, -10, 25, 0 tells me there's 1x squared minus 10x plus 25 equals 0. 2 sets of parentheses. Positive on a 25 says the signs match. The negative on a 10 says they better both be negative. 5 times 5 is 25. Or more specifically, -5 times -5 is positive 25. And of course, -5 plus -5 adds up to -10. And so our second and third solution are identical. It's just going to be 5. So our solution is 2 and 5. 2 came from synthetic division. The 5 came from factoring. Ooh, I see that 64, that last term, and I'm thinking, hey, that is 4 to the third power. I can quickly check. 12 is 4 times 3. And then if I really want to be super sure, I do 4 times 4 is 16, times 3 is 48. But sure enough, it's just x minus 4 to the third power, right? I recognize 64 as being a perfect cube. Look at one of the charts on the wall. And of course, 4 times 3 makes it 12, so I'm pretty sure it's a perfect cube before I even check that 48. So there's only one solution, just 4. Right? I should not be spending a whole lot of time trying to solve an equation like that. Okay, again, I look at the last term, which is a 12. That is not a perfect cube, so I'll go to synthetic division. I'm going to try good old reliable 2. Fortunately, that works. I'm left with 1x squared minus 7x plus 6 equals 0. 2 sets of parentheses. I know it's going to be x times x. Plus on the 6 says the signs match. The negative on the 7 says they're both negative. And I'm thinking 6 times 1 makes 6. And I'm thinking 6 plus 1 makes 7. And of course, with those signs in there, it works out. Negative 1 times negative 6 is a positive 6. Negative 1 plus negative 6 is negative 7. So my answers will be 1 and 6. And so our solution set, 1, 2, and 6. The 2 came from the synthetic division. The 1 and 6 came from factoring. All right. And then one of the sneaky ones of the bunch, that 512 is a perfect cube. So I'm thinking, hey, I'm looking at x to the third minus 8 to the third. And so I know I'm going to have x minus 8 times x squared plus 8x plus 64 equals 0. Again, take a look at your notes that have that, or look at the posters on the wall that have the equation for the difference of cubes. Obviously, one of the answers is 8 from the x minus 8 equals 0. We have to use the quadratic formula on the other part, but remember, whenever it's a sum or difference of cubes, the minus b over 2 times a is all I really need to figure out, right? Because I can take that minus b over 2 times a and say, hey, negative 8 over 2, that's negative 4. And I know after the plus or minus, whatever digit I had, in this case a 4, I know it's going to repeat with an I root 3. Right? We did that one day in class where we went through, 4 examples and a couple on the worksheet. And every single time, whatever digit was right before the plus or minus repeated after the plus or minus with an I root 3. And again, that shortcut only works if we start out with a sum of cubes or a difference of cubes. If we're just using the quadratic formula in any other situation, we cannot make that assumption that that shortcut will work. And so we got 2 solutions from the quadratic formula, 1 solution from the factoring. And so now you've got the steps laid out to be successful. And we can get to work. Just think about where those steps can lead us.